All right, I guess it's 11:10. Good afternoon, everyone. Thank you for here on Saturday morning. Before we start, I want to say my sincere regards to the volunteers, PCA volunteers, as well as our sponsors, without which we could not make it here, right? Thank you all the sponsors, volunteers, and everyone. Before we begin, quick questions. How many of you are familiar with APIs? Everyone. How many of you have built the APIs? Okay. So this session is going to be a foundational 101 for APIs and how you can leverage APIs for different business cases. This is not some super fancy AI stuff, no LLMs. I wish I could talk more about the MCPs, but we are short of 30 minutes. We don't have time. There are too many things to cover. So I'm purely focusing on just foundations of API. What are the things you need to know? How API works, and what value you as a PM add to the entire ecosystem, and how you can add that value. And if there are any questions, I would be glad to answer. Sounds good? We'll cover two things. Just foundations, pure. We are simply learning how to build a car, not running on the highway, right? Simple stuff, gears, tires, wheels, engine, that's it. We are not building a rocket. And how do you add a value as a PM? So what is API? API is essentially a communication language between request and response, between requesters and provider. You go to a restaurant, you ask server, bring me food, server gives you menu, and based on that menu, you order the food. You don't go to the kitchen, you don't ask the chef to bring me some particular salad or pasta or pizza. You ask that to waiter. Waiter conveys your request to the chef in the kitchen. Chef prepares that request for you, and you get the food, right? So in this entire system, server is your API. Nothing fancy, simple. He takes your request, delivers to the provider. That provider fetches or processes the food, and you get the food. And the server fetches out the response to you. Now, what is the menu card in this case? Right? You go to the food court. What is the menu card? Right? There, you don't have servers. You don't have waitress. Right? How do you get a food? You have a menu card, right? Menu card is your API contract, right? So any API, essentially, be it SOAP, REST, GraphQL, RPCs, essentially is a contract between the requester and the provider, right? And API is a way of delivering that contract. This is the promise you are getting. When you go to your banking account and when you see, check my balance, that is an API request, which is going to the bank server. Bank servers looking at your balance and giving out the information to you, right? Before you operate or build APIs, right, you need to understand the foundations. I'm taking just REST APIs here as a foundation. And these are the things which you should know inside out, right? These are your foundations on which you will refactor the platform. You would integrate with third-party platforms. You would build your applications. Nowadays, LLM see your API docs, right? They don't talk to you. They don't communicate to you. You don't have a customer support. customer success team, right? LLM directly fetches out your website, see your API docs, fetches out, and write down the code to integrate those, right? But you need to understand what are the API docs, right? I'll show you the example, but I'll go over these 10 points very briefly, very briefly, because we have limited time. Request and response, I just merely talked about it in REST context. So requester puts the request, and you get a response from the API server or servers. Endpoints are the place where you actually hit the APIs. When you go to the Google or YouTube or Facebook, right, you are hitting their endpoints. And when you are going to the Facebook and you are seeking your friend's profile, right, you are passing that endpoint with a query of your friend's name, right? HTTP methods, there are popularly 4 methods: get, put, post, delete. And those are the interchangeably used to get you all kind of information, which you should know. Now, REST is essentially, REST treats all the data as resources, be it text, be it audio, be it video, be it image. Everything is treated as a resource, and the resources are transferred between each API call. When you are requesting any image, when satellite image or any friend's image, you are asking for that particular resource, you are passing the get HTTP method, get particular URL with the query of that picture name, and you are getting that response as a picture, right? Similarly, you need to understand the success and error codes. 200 success codes, 400 server failures, 400 client failures, 500 server failures. I understand it's very foundational. You need to understand the auth and authorization, different API calls, headers, API payloads, API testing, right? So these are your 101 foundations. You need to understand those inside out before you go and build any product, right? Before you go to talk to engineers and give them your requirement, before you talk to your customer and understand their business workflows, before you understand your organizational business workflow and map it to the APIs, right? So these are very foundational API foundations. I'll showcase you. I took out the Spotify, right? So this is the documentation from the Spotify. Let's say you are building any new application or fetching the Spotify playlist, right? Look at the beautiful way they have created the application. This entire suite is a product suite, right? They have treated it as a product. They have given the tutorials, how to do that, how to access particular API endpoints. They have given the request samples, response sample, and if you go to that website, they have shown you the different request and response for different error codes, 200, 401, 403, 429, right? Now, similarly, you can get for public-facing APIs website like YouTube, like Stripe, like Square, like PayPal, Visa. All those are fantastic product suite, right? They have treated their API very carefully, and they have make sure the developer actually able to consume those APIs, right? So the concepts which I was talking in the previous slide are applied here. You can see the get is the HTTP method. It is hitting the artist/ID endpoint. ID is the parameter for it, and these are the request and response you are getting, right? This is API 101. This is the basics of APIs, right? You need to understand this before you refactor any code, before you make any microservices-based platform, before you integrate with your Square or your fancy tools, right? This is the basics. This is 101. Right? Now, this is the typical ecosystem you're operating in. As an API product manager or product owner, you're a product manager, you're working with engineering teams consisting of a bunch of engineers, engineering lead, multiple engineering teams, right? You're working with customers. Those customers can be internal customers, those customers can be prospects, those customers can be public-facing API, so it might be B2C product, right? And you have a business sponsor, one who is sponsoring money for that, right? Maybe it's a business lead, maybe it's a director, maybe it's a VP, maybe it's a CEO in case of startup. So you are working with these multiple folks. And this is typical for any kind of applications, not only APIs, mobile applications, web applications, backend integrations, so on and so forth. Correct? Now, these are the typical business cases of using APIs everywhere. APIs like a car, which are taking you from one place to another, right? Third-party APIs, right? You're building your app and you want to integrate payment system. You need to integrate their third-party APIs. You are building your own applications and you are exposing it within the organizations or exposing it to third-party public, right? You need your application. You need to expose via API, right? There can be numerous business cases, but nowadays, all the communication happens only through API, right? It can be SOAP API, it can be RPCs, it can be REST. Mostly it's REST, but there can be different APIs, GraphQL, but API is a means of communicating the data, information, and information. Now, okay, before you start operating as a PM, these are some of the things you need to understand within your team, within your organization or team. And that will help you create value for everyone else down the line. You need to understand you need to understand your business flows and data flow inside out. When let's say you're working at Amazon and customer is coming to Amazon.com, how it goes to Amazon.com, to different websites, to different layers, to public, and how the customer selects the product, adds to the cart, go to the payment system, and check out the product. You need to have a thorough understanding of your inside business flows and how the data is flowing inside out, right? Ultimately, the API server provides the data from the data source you have. It can be data lake, it can be data warehouse, it can be databases, it can be files, right? But API fetches that data from some of the data sources which you own, right? You have a front-end application, you have a middleware application, you have a data sources. The API is the means, is the plumbing which communicates to front-end or to customer or to any middleware and through in an entire ecosystem. So you need to have how the customer journey looks like, and you need to understand the mapping of, for each customer journey piece, what is the data flow you're looking at, right? You need to understand, let's say you're refactoring the application or you're building some of the services for some existing layers, right? You need to understand the API orchestration. You need to work with architect, technical lead to understand, hey, show me how the entire data flow works. You want to understand that entire orchestration, right? Uh, Once the customer hits the website where that API hits, right? Uh, it hits to intermediary system. That system hits to other system. That system hits to other system. And what are the contracts? What are the trade-off? What are the transaction happens? And finally, where the data is fetched from, right? This helps you understand the entire architecture or system, and this helps you design your APIs or new products really well. You need to understand the API building process of your organizations, how you are designing API, building, developing, testing, and publishing it. You need to understand how your consumers are consuming your APIs, why they are consuming it, how they are using it, what are their business problem, you're solving it. You need to understand that entire ecosystem. And what are your approach of productizing APIs? Based on this information, are those APIs will be used within internal teams, or are you publishing it to the outside world? How you're going to document it, how you're going to publish it, are you going to provide tutorials, sample codes? How can the other developers start consuming your APIs? Because in the API, your customer is developers. Your customer is architect. Your customer may not be the end client, right?
Yep. So a couple of points that you made here is, one is, when I've worked with product managers that manage platform products, and so, and I reference that because a lot of those can be called via APIs, that they often think of their customer being the product architect who needs to call that. But your point of how are your consumers consuming it is so critical, and that's the point that I always try to get across from them. Don't just look at what your product architect is telling you. Look at the use cases that they're trying to support. You know, the multiple use cases. That's going to make you do a better job defining your platform or defining your API.
Exactly, right? When you build any single API, right, you need an infrastructure to support it. You need engineering bandwidth to build it, maintain it, support it, right? And all those cost money, right? So whatever single decision you are making is affecting ROI. So before you design any APIs, it is highly critical to understand the workflow and how your customer is going to use it and why it is going to use it, right? In case of Square, their customers are all food truck, right? So their food trucks are going to use the Square platform, right? It is going to be used for payment, but they understand the entire customer engagement journey. When customers, which are users coming to buy some food, right? How that journey is going to get done, they understand that. And based on that, they have designed those APIs which are scalable, right? So these are the basic things you need to understand within each team, right? Each team has a different flavor of operating. Each company has a different flavor of operating, right? But before you start working, before you tell engineers to build something, if you understand this, you are valued more. You would be treated with awe, with tremendous respect. Okay. Now, product managers adds value to everyone in the ecosystem. I'll start with the customer. Then what is the value to engineering team and what is the value to organization, right? A product manager may not build the API. Product manager will just tell the team what to build and give me that, right? In API's case, right? Most of the time, customers are developers, technical architect, leads, right? If they are not able to consume your API, your entire effort goes into vain. All that money, all the time goes wasted, right? So you need to, let's say, OpenAI or Anthropic build new models, but you are not able to consume it. What's the use, right? They are exposing that model through API, right? So along with the model, they have phenomenal investment in API product teams with technical writers who are writing the beautiful product documentation. You can go to Google, YouTube, FANG companies, any other companies which are B2C companies. Most of them, even if you go to the x.com or Instagram, if on different social medias, they would provide you with phenomenal API documentation, right? And before doing that documentation, their purpose is to have superior customer experience. They want to reduce the onboarding time of consuming that API and building the first application. They want to create all the API authentication, authorization known, sample codes given, tutorials given, all the request response structure, all the standard error codes for particular API endpoints given, so that customer can do the faster integration and with reliable documentation. Right? Let's say you are working on some product which is integrating the DoorDash APIs, right? You're creating a service just for a PIN code, right? That's your startup. Nothing wrong in it. And for that, you are using the DoorDash leverage service, right? You're leveraging their API. You need to make sure that your application can consume the DoorDash API. And the DoorDash team actually wants you to consume it easier. So they have made significant investment in the DoorDash team. It should be self-servicing. It should be reduce the debugging time. If I onboard your APIs and I have some errors, or your API is not giving me the result as per API contract. Say OpenAI, I'm connecting with OpenAI and they are not giving me correct result, right? I need to debug it. I need to have that reduced time. I cannot have incorrect API, unreliable API, right? Otherwise, I wouldn't connect with the OpenAI, right? That's why they spend significant chunk of money with API product manager, technical writers, and entire ecosystem. Because they are thinking in terms of ecosystem, they are not thinking in terms of single APIs or bunch of suite of APIs. Now, value to engineering team, right? You are a product manager, you are working with customer, understanding their business flows, you are working with business, understanding what they are doing, working with prospective deals, working with different customers and requirement internally. Finally, engineering team is the one who is going to build your APIs, right? The single most biggest value you can give to them is to give clear definition of functional and non-functional specs, right? Standard request response structure with API specs, open specs, Swagger document with success criteria, with failure criteria. In case of non-functional requirement, you are thinking about what is the rate limiting, what is the throughput of it, how much TPS that API can support, how many systems it can support, right? Let's say you are building some healthcare related product, right? And that product, that API is really slow. Will you deploy it into production? Is it usable? No, right? So if you want some, let's say you are running a Netflix and you want to watch a movie and that movie suddenly just stops or just buffers. As a customer, will you go there and watch? You won't, right? So you need to consider the non-functional specs as well. You need to understand the API orchestration and showcase that API orchestration to your engineering team. You need to showcase, I'm getting requests from client from this application. This application will internally call another application. Another application will call this application with different request and response. What data sets, what parameters a different application is passing or collecting. You need to have that understanding, and you need to showcase that understanding to your engineering team. Once you showcase that, that is a huge value to them. All these fundamental steps, foundational steps, once we do it right, it leads faster time to market. It enables partnership. Say, I'm a company like Remedy or Wise, which is transferring money. My core business is transferring money across the geographies, and I want thousands of partners to onboard me. I don't know, but I'm just making things up. I want to create a leverage, right? If I did my APIs well, my thousands of supporting vendors or partners can consume my API and build own applications for them. And indirectly, it will become entire ecosystem, right? Suppose you're traveling and you're going on Airbnb or Booking.com or Expedia, right? And there are partners of Expedia or Airbnb or Booking.com, but the partners are not able to consume that API, or there is too much lag. What happens? The entire leverage of those companies goes to the dust, right? So if you do the API right with the right specification, you enable that partnership, and that multiplies your ROI for executives. Similarly, it increases the scalability, right? I was talking about the Square. Square is a beautiful example. Square itself is a platform, right? It is Square, Toast. Those are payment platform for SMBs. They are supporting to the food trucks. Now, the food trucks doesn't have infrastructure to build phenomenal tech. They don't. They are just good at preparing the food, delivering it, and collecting the money. But they have entire problem running their restaurant chains, collecting the money, collecting the inventory, building the recipes, right? Managing the workflows, managing their employee work hours, so on and so forth. So Square has designed the platform, and that platform is utilized by hundreds and thousands, and it can be easily scaled to millions of consumers. That increases the scalability. So only one team of 5 to 10 people, or maybe 20 people, depending on the complexity, depending on the architecture, if you build that API system right once, right? Because you don't change the API constantly, you are very conscious about the version control. If you upgrade your APIs to the next version, like frequent upgrades, right? You want to make sure your previous version doesn't break. That is absolute critical. And similarly, it unlocks the new revenue streams. Take me any business, I can show how it can unlock new revenue stream, right? I just showcased the Square, but let's talk about the travel website, Airbnb, Booking.com, Expedia, right? They are looking for say travel just for educational travel for kids. Those are the segments they are considering for teenagers or for high school kids. What they would do is they would map that business flow. They would map the customer journey. They would figure out for each customer journey what are the different data points they need to get. Based on that, they would create the API orchestration. Based on that API orchestration, they would give the requirement to engineering team. Engineering team will build those APIs, those will be validated, thoroughly tested, and then it would be published onto the production servers. And once those APIs are published, you can have hundreds of applications consume that API, or different application integrate with your new revenue stream, which is business travel, education travel for kids, right? Those are the segments you are tapping, right? And once you build that foundational block, it is scalable, right? Similarly, if you want to do any startup, right, and you have a team of 5 people who are working together, they have fantastic idea, and they want to reach out to thousands of customers, right? They cannot go and call hundreds of customers, right? Instead, what they would do, they would partner with different IVR websites. They would partner with different delivery websites. They would partner with different platform websites. They would partner with different cloud websites to have that as an integrated suite. And on top of that, they would have their application. And that application will give end-to-end customer experience for their customers.
So one of the questions I have is, we definitely know there's a lot of advantages using APIs.
Sorry, I didn't catch you.
Oh, there are many advantages in using an API-driven architecture. And I know this because I have clients that I've worked with that have a very monolithic infrastructure, and they're just having a hard time staying up to date, evolving their platforms, et cetera. And it takes a lot of engineering resources too to keep that maintained. But so, the trend is, let's make this built more on a more API, microservices type structure. But is there any disadvantage to that? So you talked about, an architecture where your application is calling, it may be some of your APIs, it may be partners, other web services. At what point are there disadvantages in doing an architecture like that?
There are some possibilities of disadvantages of API, right? So if you are building an API which no one consumes, right, or very few people consume, so you are planning to consume it for 100,000 people and only 500 people use it, right? That your investment is going to the dust, correct? Second, if your API in the architecture, they are calling to multiple internal APIs, right? Because normally there won't be any 2 or 3 APIs. There would be a bunch of 15, 20 APIs which are calling internal APIs, right? And if some of the internal API breaks down, right, you should be able to debug it quickly. You should have the entire support structure, logs, alert, monitoring tools, telemetry, everything to identify what was the root cause and fix it quickly.
Wait a minute. How does that, you would need to do the same thing with a monolithic architecture, right? I'm trying to understand where you're drawing the line.
So I'm not comparing with a monolithic architecture. I'm just saying that what are the disadvantages of that.
Okay, but I thought he was saying, like, how do you choose between an API, microservices and monolithic?
Yeah. So monolithic, it's harder to scale, right? Monolithic is harder to build new application. Monolithic is harder to maintain. So you have a zillion gigabytes of code. If something breaks down, to just debug it, it takes you days, time to fix. Sorry, yeah.
Yeah, so like I think I'm still like this question's really interesting to me, which is like, why would you not do microservices and like why would you do a monolithic thing? And is it because like when you build APIs, your customers have to be like highly technical developers, and if you're like a business that isn't serving developers and you're just thinking about like the basic business, you would be more likely to.
Both internal and external.
Yeah, so I mean, I think you have to separate the internal versus external.
Okay.
External, it's like, it seems like it's absolute no-brainer.
Absolute no.
Yeah.
But building your own
but-
internal architecture.
But internal, if it's a purely internal, I would say that, and I think where you're getting is, anytime you're having handoffs, like that's a failure point.
Yeah.
And the microservice was really easy to debug that handoff.
Okay.
Now, in concept, you could really get too complicated, and you like call every time you call two tables a handoff, and that might get crazy. But when there's a fundamental thing of like this data resides here, this data resides here, I have all this integrity, and I want one to call the other, the microservice model just seems to make a lot of sense.
So what you're saying is, I think I'm still confused. The handoff is a potential failure point.
That's like there's two types of failures in a process. It would be you have this fundamental handoff where one thing is contacting another.
Yeah.
And that's where if one thing goes down, then you figure it out.
And so those things could be the microservices, right? So
I'm
every
just-
time you have all these microservices
Yeah.
instead of monolithic, you have all these different opportunities for failure.
I got it.
Right, but then I think he was also saying
Now-
something about tables.
No, if you're saying that was taken to the nth degree. Like you're always calling various tables but yeah, I'd say that.
So I'll
you could take it.
Yeah. So there are multiple parameters. First is performance. So performance of microservices
okay,
is superior.
Yeah.
Second, additional of new functionality. To make any changes in the monolithic architecture, it can take you months. Nowadays, you're doing it few hours, but you can't afford to do that, right? If you want to, imagine Amazon is a monolithic. It's not, but imagine if you want to make any changes in shopping cart or any functionality, it would take them month. They can't
You're
afford.
saying in a monolithic versus.
Yeah,
I think
in
I still-
microservices. So in microservices,
Which one's the advantage?
so microservice is clearly a hands-on because you have 10 different teams focused on different functionality,
Yeah.
and you are particularly vertically upgrading each functionality, right? And each team is only responsible for outcome of that through APIs, right? So whatever happening is internally, no one needs to know, correct?
Basically, from the APIs are public face.
Correct.
You're in the
Exactly.
and everything-
APIs are public face, be it internal or external, in case of microservices. In case of the other problem is a data flow and let's say you have a common database or common data lake, right? And multiple microservices are hitting the same data, right? One is allowed to change, one is not allowed to change. Now that is little complexity. It needs to be thoroughly thought through. In case
you
of
have to update every API, so then
that architecture, so data sharing architecture inside the microservices needs to be think through. It is not that easy.
How different is the regression testing with microservices versus monolithic?
Monolithic, it will take a couple of weeks, couple of days to weeks. So I wouldn't call weeks, but at least 1 to 2 weeks, at least.
To regression testing, okay, and for
APIs, it should take 1 or 2
when you
days.
say APIs, either way you have an API, you mean microservices?
Microservices.
Okay. So
Microservices shouldn't take more than 1 to 2 days max.
I mean, a point I think you're getting at, and I know is on some side, is the whole thing of like, with API, you're really formalizing authorizations and authentications.
Mm-hmm.
So the challenge, if you have it, is just this one data lake. It's like, well, how do I permission everything? And this basically, and so like, it's almost like any fundamental permissioning is another formalized handoff that's just easy to like, okay, here's the definition for it.
Duplicate that across all of your microservices?
You can, it depends on your architecture, but authentication provides you only these are the users which are allowed to do that. And
Could you write a policy and have the policy
Yes.
determine all the different microservices?
Yes.
Are you familiar with that concept?
I know a little bit about policy because I worked in security, but I'm a pretty new PM, so.
Okay.
My background's in UX, so I'm like, okay, I'm piecing this together.
But basically, yeah, he was right? Authentication and authorization, right?
Yeah.
Authenticating certain set of users and authorizing certain set of resources. That's
Yeah.
it. You are allowed to use this notebook. You are allowed to use other set of notebooks. You are not allowed to refer to his notebooks, right? And that is just hard in monolithic.
I think it's just all stuck in the code and trying to figure out.
Oh, sorry. What is the advantage to building monolithic? Does it just take less time? Is that why people do it?
No.
So
No.
what, I just thought, like, why is not everybody building microservices?
And it's just, I'd say, I would just say one would be like maybe historical, like it's
Oh, it's
just,
like a use
it's
to-
legacy.
Okay, it's just not modern.
And then sometimes, it's like, and this is just like, like not vibe coding, but just think the general of like getting a beta out there. And you're thinking very linearly.
Yeah.
And almost like a generalist mentality where like you build it like this, and then as you grow and you just scale, then you're thinking vertically and like, oh well, this is the weak point,
Got it.
and maybe an API like, and then you could build later.
Yeah.
That would be a real generous way of saying like you didn't. Yeah, like sometimes you have to get something out and then you kind of go back and refortify.
So like just now when you said API, are you using the term API and microservice interchangeably?
I'm defined to consider just an API exactly like that. Like basically a formalized protocol where there's an input, you get the output.
Each API essentially is a service, right? Service, right? And it is hosted on some server, right? Now the microservice architecture means you have bunch of small set of services which are focused on those kind of, right? So based on the complexity and granularity of your request and response or your services, it can be microservice, it can be a large service, right? Yeah, that's what.
Here's the challenge that I've seen. So when I've worked with primarily financial services, healthcare, and
Yeah.
telcos,
Regulated.
they have like multiple of these monolithic systems that sit in place. And it's gotten to be is where we want to change one of the products that we offer to our customers. They have to touch all of these systems, and there are certain people that know each how to work on those things. And I remember working with telco, and it says it takes us 6 months to offer a new telecom service. And your competitors are out there and launching new ones in a day or a week.
Yeah.
And the other thing is that the only way they can manage, and there's always these dependencies, and so the only way they can manage these dependencies is by implementing SAFe. And SAFe is not agile.
Yeah.
It's a way to implement some agile practice, but it's not safe or it's not agile. And you hear a lot of people slam it, but in their case, that's the only way they can do it. And so by having at least some level of APIs or microservices in place, you now can be much more dynamic in making an update here, not having to wait for this to happen or et cetera. And so I think there's a balance. I think was the point you're getting to is that you don't want every single thing to be an API, but there's a certain level of it you want it to be so that you can have that be more dynamic.
Essentially, you are slicing the functionality of entire monolithic into small functionalities. And those functionalities have dedicated data or that data policy is thought through. That's what the organizations are working towards, right? Breaking into small microservices, but entire data lake. They have to think through it. And I got last slide. I know we are running out of the time. So this is also, you add a value to organization by designing the entire API governance. How your APIs are designed, your swaggers are validated, built, test, and published, right? What is your testing? And this is across the team. Productizing API as a product. A lot of teams, a lot of companies just build the APIs, right? They don't have product docs, they don't have sample codes, they don't have tutorials, they don't have other collaterals, right? That entire collateral and support structure makes it as a product, makes it easy to consume. Documenting APIs with the business flows, right? If you understand the entire business flows, mapping it with the data and aligning different APIs for those datas or mapping it, showcase that adds value to everyone in the room, right from the developer to CEO, right? If you know something is breaking, any team can just look at that document and go to the right place and fix it, right? Your debug time, your fixing time improves. If you want to add new functionality, if you want to scale it up, you know what you need to do in terms of cost, in terms of investment.
All right.
And API.
Thank you.
Thanks so much.